So in the last lesson, what we talked about was expressions whose exponents were fractions with numerators equal to 1. And that was like if we had something along the lines of 7 to the 1/3, that really meant the cubed root of 7. Or if we had 9 to the 1/5, that really meant the 5th root of 9. Notice how those numerators were all 1 and 1. Now what we want to investigate is what happens when a numerator doesn't equal 1. Well, basically we're going to use the same skills that we used in the opener to evaluate this expression. Now, in the opener we said that 8 to the 2/3 can be really rewritten as a product of 1/3 times 2, because 1/3 times 2 would bring us back to 2/3. Now, we want to use the laws of exponents to really evaluate this expression. 8 to the 1/3 times 2 can really be rewritten as 8 to the 1/3 raised to the second power, because we know that anytime you have a power raised to another power, all we do is multiply the powers, which is what we had here when we're multiplying the powers, and 1/3 times 2 brings us back to the original, which basically just means that this here is the exact same thing as this here. We haven't changed anything yet. Now, 8 to the 1/3, we can do a little work with this too, because 8 to the 1/3 is really going to give us the cubed root of 8. And the cubed root of 8 means what times itself 3 times will give you 8. We could evaluate that. That number is going to be 2. And 2 squared, that really equals 4. So that's how we can actually go ahead and take 8 to the 2/3 and evaluate it and find out that the answer is 4. So what I'd like you guys to now do is kind of just follow along with this one more time. Let's go back to the beginning. 8 to the 2/3. We said we're going to take this and rewrite it as 8 to the 1/3 times 2. All we did is took the 2/3 and rewrote it as a unit fraction multiplied by an integer. Now, 8 to the 1/3 times 2, we use the laws of exponents just to throw some parentheses around the 8 to the 1/3, because when you have a exponent raised to another exponent, all you do is multiply those two numbers, which is what we were doing in the beginning. And 8 to the 1/3 is really the cubed root of 8, and the cubed root of 8 is just 2. So 2 squared equals 4. And that's how we found out that 8 to the 2/3 equals 4. I'd like you guys to now take a moment and answer question 1 off the core activity. Evaluate the expression 8 to the 2/3. For each step in the process, provide a justification. For example, the property used. So 8 to the 2/3. How do we go from 8 to the 2/3 to 8 to the 1/3 times 2? And what's the justification for that? Pause the video right now, take 1 minute exactly, try to fill in all of these blanks, the justification or the reason we can go from one step to the next. Just problem number 1 from the core activity. All right, 8 to the 2/3. Why we can make it 8 to the 1/3 times 2? Well, that reason is just because 2/3 can be rewritten as the product of 1/3 and 2. All we did is took that and rewrote it as the product of those two things. Now we can do 8 to the 1/3 times, or I'm sorry, 8 to the 1/3 to the second power, and the reason that we can rewrite that is the laws of exponents, specifically the laws of exponents that talk about raising a power to another power. So why we can do 1/3 times 2 is really 1/3 squared. Now 8 to the 1/3, why we can take that and rewrite it as the cubed root of 8. 8 to the 1/3 equals the cubed root of 8. And that really is just because we focused on the meaning of a fractional exponent. Eight to the 1/3 means the cubed root of 8. That's just the meaning of a fractional exponent. Why we can go from the cubed root of 8 to just 2? Well, that's because 2 times 2 times 2 equals 8. Or a little easier to write here would be 2 cubed equals 8. 2 times 2 times 2 does equal 8. So that means that the cubed root of 8 equals 2. And the last one, 2 squared, well, that's just 2 times 2, and that equals 4. So that's why we went from each specific step. All right, let's keep going here. And let's go ahead and look at, sorry, let me pull this back up here. Let's look at the next little set. And in that animation, we saw that the value of 8 to the 2/3 really equaled 4. On the right is a graph of the function y equals 8 to the x. So this is the graph y equals 8 to the x. Compare the results of the evaluation 8 to the 2/3 to the graph. Now we said 8 to the 2/3. That really equaled 2. Let me see if I can pull this back up here. Here we go. We said 8 to the 2/3 really equaled 4. And this graph here is y equals 8 to the x. Well, in this case, x would be 2/3. So x equals 2/3. And y would equal 4. Does this graph actually show that? Well, when x is 2/3, so I'd go over right in between here, probably about right here would be 2/3. Is y equal to 4? I'm going to go up. Oh, here it is on the graph, and it is. That point where that actual line hits is the point 2/3, comma 4. Does the graph support the value that we found algebraically? Yes, it does. Because 8 to the x, when x is 2/3, y equals 4. 8 to the 2/3 equals 4. What I'd like you guys to now do is work with your partner, evaluate other expressions whose exponents are fractions with a numerator not equal to 1. You guys are going to do problems 2 through 6. So numbers 2 through 6 on the core activity. You and your partner can go ahead and work on that now. We're going to take about 8 minutes to go ahead and do this. When you are done, please stop working. We'll check your answers with what we have. Let's check your answers with what we had. You've shown algebraically that 8 to the, that's supposed to be 2/3 equals 4. Does the graph support this? Explain. Yes, it does, because if we go over 2/3 and we go up, it hits right at 4. So the graph, x equals 2/3, y equals 4. We have the x value was the fraction, the y value is what it evaluated out to be. Use the graph to estimate the value of each of the following expressions. 8 to the 4/3. Well, that's going to be 4/3, so it's going to be right about here, just past 1. We'll go up and see that it hits, well, somewhere in this area. I'm going to go ahead and say maybe about right here. That would be 10, 11, 12, 13, 14, 15. Say that answer would equal 15. 8 to the negative 2/3. Negative 2/3. Well, that's going to be almost to 1, to negative 1. Maybe about right here. Let's choose a different color for that. Right about there. That's to the negative 2/3. That looks to be maybe less than half. I don't know. I would say maybe 0.3. Right? Let's go with 0.3. 8 to the negative 1/3. Well, it's going to be a little bit less. Maybe about right here. Over negative 1/3. That looks to be about, I don't know, 0.75. 8 to the 1. Now, if your answers are a little different, that's okay, so long as they're kind of somewhat close. 8 to the 1/3. It's going to go a third of the way to 1. Here's 1. So we're just going to go a third of the way, which would be about right here. Go up on the graph. That hits about right here, which would be equal to 2, approximately. So your answer should have been in the ballpark of what I had here. Find the values of the following expressions algebraically. All right, so we want to do this using some of the laws that we just learned about. So 8 to the 4/3. We can really write that as 8 to the 1/3 times 4. And that could be rewritten as 8 to the 1/3 times 4. 8 to the 1/3 is really the cubed root of 8 to the 4th power. And the cubed root of 8, we said, was really what times itself 3 times. It gives us 8. That answer is 2 to the 4th power. Well, 2 to the 4th power, 2 times 2 times 2 times 2 is going to equal 16. So 8 to the 4/3 power equals 16. Let's go 8 to the negative 2/3 power. It's going to be 8 to the 1/2 times negative 3. Oop, no, that's not. Change that. That's going to be 8 to the 1/3 times negative 2. My apologies on that. 8 to the 1/3 times negative 2. Let's rewrite that really as 8 to the 1/3 times negative 2. That's really going to be the cubed root of 8 to the negative 2 power. Cubed root of 8 is really going to be 2 to the negative 2. And we know that anytime we're dealing with a negative exponent, now we're actually going to do this, we're going to flip it, so that becomes 1 over 2 squared, which is just 1 over 4, or 0.25. Fraction is a little bit more accurate, so we'd leave it as the fraction. So we said 8 to the 4/3 equaled 16, and 8 to the negative 2/3 equaled 1/4. Are the values you found algebraically the same as the ones that you estimated from the graph? Well, let's go back and check it out. 8 to the 4/3 we said was 16. On the graph, we said it was about 15. They're pretty close. 8 to the negative 2/3. 8 to the negative 2/3 we said was 1/4. 8 to the negative 2/3. That was pretty close, right? 8 to the negative 2/3 we said was 1/4, or 0.25, and we estimated it to be about 0.3. Again, really, really close. Are they the same? No, but very close. Between the values you found using the graph and the values you computed algebraically, which are most accurate? Explain. Well, clearly the ones that we calculated algebraically are more accurate. Because the graph is more of a guess. We didn't know exactly where 1/3 or 2/3 lies on a graph. We couldn't tell. We couldn't like pinpoint it exactly. So when we calculated it algebraically, those are definitely going to be more accurate than the graphs.